Assalamu alaikum, how are everybody? The last lesson we explained chapter 5 section 2 part 1, and we started with the first type of energy, which is kinetic energy. Today we explain potential energy. What's meant by potential energy? Suppose you raised an object from this level to this level, and you lift it. What will happen? It will fall down again. So it has the ability to move. This ability to move comes from potential energy. So potential energy is a stored energy. Stored energy. And it's called potential energy because the object has the potential to move, because it stores potential energy. And it depends on the interaction between an object and its surrounding. So it depends on the interaction between the object and its surroundings or its environment. So, potential energy can depend in an object position, can depend on object shape or conditions, or can depend on its chemical composition. Okay, so the potential energy is the energy stored in an object. Potential energy is the energy stored in an object due to its position, its shape or condition, or its chemical composition. Again, potential energy stored in an object due to its position, its shape or conditions, or chemical composition. Each one of them has a specific name. For example, the energy stored in an object or associated with an object due to its position from the ground or from earth is called gravitational potential energy. The first type. So gravitational potential energy depends on position. Shape or condition is called elastic potential energy. So elastic potential energy depends on the shape or conditions. The potential energy which depends on the chemical composition is called chemical potential energy. So we have three types of potential energy: gravitational potential energy, elastic potential energy, and chemical potential energy. Gravitational potential energy is the energy associated with an object or associated with an object due to its position from the ground. Elastic potential energy, the energy associated with an object due to its shape or conditions. The energy stored in an object due to its chemical composition and the bonds inside it is called chemical potential energy. We will discuss gravitational potential energy and elastic potential energy. Chemical potential energy is not included in our course here. So let's start with gravitational potential energy. We mentioned that it depends on what? Position. Depends on object position from the ground or from Earth's surface. As we mentioned, if you raise an object to a certain height, this height is h. Sorry, this is larger. To a certain height. So here, sure, to raise this object, force is exerted and distance happened, so we have work here. Work equals F times D. D here represents height or h, F times h. We know that work equals F times D. D here represents the height. The distance moved is the height and it is h. And F, it's the force exerted against the force of gravity. So F here represents Fg. So F equals Fg times h, because the force exerted here against gravity. If you need this object, for example, its weight or the force of gravity equal 10 Newton, you should exert at least 10 Newton to raise this object. So the force here exerted equals the force of gravity. Then the work equals Fg equals m times g multiplied by h. So the work done here to raise the object equals mgh. This work is stored in the object in the form of gravitational potential energy. So this work is stored in the form of gravitational potential energy, which is equal to mgh, and if you leave the object, it starts to move down under the effect of the stored gravitational potential energy. So here PE equals mgh. Potential energy equals mgh. M is the mass, G free fall acceleration, and h is the height. So the gravitational potential energy depends on the mass of the object, free fall acceleration, and the height. Let's discuss it with an example. You have two objects, this object and this object, 1 kilogram and 1 kilogram. Which one has a higher potential energy? The first object or the second object? For example, this height equals 1 meter and this height equals 2 meters. Which one has a higher potential energy? Let's find the potential energy here and the potential energy here. But before calculating it, think about. So here potential energy equals M 1 kilogram, G equals 9.8, and H equals 1 meter. So in this case, the potential energy, gravitational potential energy, equals 9.8. What's the measuring unit of potential energy? Any form of energy, joule. So this is the potential energy of the first object. What about the potential energy of the second object? PE equals the mass here equals 1 multiplied by 9.8 multiplied by the height equals 2. So in this case, the potential energy equals 1 times 9.8 times 2 equals 19.6 joule. So the first object has a larger potential energy because it has larger height. So as the height increases, the potential energy also increases. This is the first factor that affects the potential energy, which is height. The question now, an object at the ground, its height equals 0. So in this case, the potential energy equals 0. An object on the ground, its height equals 0, and its potential energy equals 0. Pay attention here that the potential energy, the height, is taken from a certain level, is arbitrary, can be chosen from a certain level. For example, if a ball drops from the second floor to the first floor, if you take the first floor to be the 0 level from which you measure, so the potential here equals 0. But if you take the 0 level to be the ground, in this case the ball here has potential energy relative to the ground. So we measure the potential energy or the height from 0 level. We choose a 0 level from which we can measure. The second factor, which is the mass. This object, 1 kilogram at a height of 2 meters, and this object is 3 kilograms at the same height which is also two meters. Which one has a higher potential energy? The first object or the second object? Here let's find the potential energy of the first object equals M 1 kilogram times G 9.8 times height equal 2. So the potential energy equal 19.6 joules. And the second one, potential energy, gravitational here, sure, equals mass 3 kilograms multiplied by G 9.8 multiplied by 2 meters. So the potential energy, gravitational potential energy, in this case equals 58.8 joule. So the larger the mass, the higher the potential energy. The larger the mass, the higher the potential energy. So the potential energy depends on mass and height. So here, for the last time, PE gravitational equals mass times free fall acceleration times height. This is the gravitational potential energy. Okay, guys? This is the first type of potential energy. Now, the second type, which is elastic potential energy. And we mentioned that the elastic potential energy depends on the object shape or conditions. How? For example, if you have a rubber band and you stretch this rubber band and you leave it, it will move or vibrate. So by stretching the rubber band, it stores elastic potential energy. So this is a rubber band also. So by stretching, if you have a spring and if you compress this spring, and you leave it, it starts to move out. Okay? Or if you also stretch it and leave it, it will start to vibrate. So stretching or compressing an object, stretching or compressing an object, the object stores elastic potential energy due to stretching or compressing. So stretching or compressing an object stores elastic potential energy, like the rubber band, like the spring, and so on. Elastic potential energy, elastic, equals 1/2 kx squared. What's k and what's x? K is called spring constant and depends on the spring itself. Depends on spring. If you have light spring, it's different from another one. So the spring constant here is different from the spring constant in this one. So it depends on the spring itself. For light spring, it will be small, and for heavy spring, it will be large. So this is called spring constant. And x represents the stretched or stretched or compressed distance. How come? If the spring has a length of 20 centimeters and it is stretched to become 25 centimeters. So in this case, x equals 25 minus 20 equals 5 centimeters. So here x represents the stretched or compressed. Also, here the difference between this length is called relaxed length, without any force. The length of the spring without any force here is called relaxed length. What's relaxed length? The length of the spring without any force, without any external force. It's called relaxed. If the spring is stretched, its length will increase. The difference between the increased length and the relaxed length is x here. Also, if you have a spring, its length equal to 20 centimeters, relaxed length, and if you compress it to become 17, so x here equals the difference between them, which is 20 centimeters minus 17 equals 3 centimeters. But pay attention here that x should be in meters. So x in this case will be 3 centimeters times 10 power negative 2 to become in meters. To convert it into meter, from centimeter to meter times 10 power negative 2. In the first case, x here equals 5 centimeters. It would be 5 times 10 power negative 2 meters. Okay, clear? So the distance here should be in meters. Let's discuss an example. A spring of spring constant (100 Newton per meter). Here the spring constant is measured in Newton per meter. Its length equals 20 centimeters. It's stretched to become 25 centimeters. Find the elastic potential energy. So, solution given here. First is the spring constant. K equals 100 Newton per meter. And its length, the relaxed length, 20. and its length after being stretched equal 25. So x equals 25 minus 20. So x equals 5 centimeters. After converting it into meter, it will be 5 times 10 power negative 2. Okay. So, elastic potential energy equals 1/2 k x squared equals 1/2 times k spring constant equals 100 times x 5 times 10 power negative 2 squared equals 2.5 times 10 power negative 2 joule. And this is the elastic potential energy stored in the spring due to stretching it. Here guys, I think the subject is simple, and this is the last point in our discussion today until we meet again the next time, inshallah. Thanks a lot.